Today, I'm here to present our research titled AWFCNet, an attention-aware deep learning network with Fusion classifier for breast cancer classification using enhanced mammograms. I'm Renato Maaliw III. On behalf of my co-authors, it's my honor to present this paper. For the introduction, breast cancer remains a significant public health concern and a leading cause of female mortality despite the advances in healthcare. In 2021 alone, there are 2.5 million breast cancer cases, 630,000 deaths. So breast cancers has a total of 26% of all cancer cases, mostly on women. Despite the innovation interpreting breast cancer using various methods, it still has encountered some difficulty. It's still time consuming and inconsistent. Comparing benign and malignant tumors are complex as their differences are subtle. Artificial intelligence approach is paramount to improve prognosis and supporting expert decisions to ensure uniformity, increasing objectivity while decreasing subjectivity. Over the past decade, scientists and professionals experimented with new methods for breast mass segmentation and classification. There are classical machine learning models that were used to discriminate healthy and cancerous samples. However, they are limited accuracy. Recent deep learning predicated on CNN showed significant improvements, but still are limited with the capability to uncover latent image scans. These dilemmas were due to noisy and hazy image scans contributing to misdiagnosis. Several scholars have suggested deep learning network layers with classification accuracy ranging from 90% to 97%. Based from literature analysis, it reveals that computer aided diagnostics is progressing swiftly in breast cancer detection, incorporating various methods. However, we are optimistic that there are still unfilled gaps, as artificial intelligence can quickly convey a cancer's finer details better than the naked eye, specifically in its early stages. To move the science forward, we propose an automated pipeline based on attention aware CNN, reinforcement learning, and extended preprocessing procedures. We also designed a fusion classifier at the architecture's end to stabilize classification for a more generalized result. We codename our architecture AWFCNet. Our research can help oncologists evaluate breast cancer earlier to deliver timely patient treatments. So for the methodology, we use 322 high-resolution black and white mammography scans subdivided into three distinct and equal categories. So original data has 64 benign, 51 malignant, and 207 normal. Because of the disparity of the numbers, so we obtain additional data to balance out each category to the size of 207. Image are normalized to 5 by 12 pixels to compensate for size differences. So as you can see here are the samples of the MIAS data sets, different cases of breast cancers from benign, normal, and the malignant. Data augmentation. So we perform a single transformation to generate additional 621 more images with a total of 1,242. So 414 for each classes. We partition the final data set into 80 to 20% training and testing split with a tenfold cross-validation. So for the color shifting and image enhancement, we prioritize the green channel to have more final details of the mammogram. So another one, we implemented a spatial vinyl filter with filter size of 4 by 4 to increase the image features. So figure 4 denotes the sample colors shifted from A to F1 with its enhanced version A2 to F2, with refined breast tissue details using a special Wiener filter. So for our residual network, we use a ResNet XT. It's highly effective for allowing diversified and fine-grained feature learning due to its cardinality feature. So the mechanism also facilitates information flow better with computational efficiency. So this is the architecture of ResNet XT. So for our proposed AWFC Nets architecture, so we have the input image, the preprocessing, data augmentation, color shifting, including the enhancement. So for our special neural network, we pre-trained it using the ImageNet, but with extra layers for attention-aware module based on ResNet XT 101. Then we have at the end recurrent neural networks, three recurrent neural networks of stacked bidirectional long short-term memory networks, gated recurrent unit, and ESN with a hard voting ensemble to predict the breast cancer classification. These are tested on a tenfold cross-validation and evaluation of the overall performance classification and explainability. So for the image enhancement, we used the special Wino filter evaluated using the VIF or the visual information fidelity. So for the classification performance, the standard measures of F1 score, precision, recall, and accuracy. So for the visual interpretability, we used a gradient widget class activation mapping plus plus. It is an extended version of the classic GradCam that will help us visualize how the model is classifying the images. So for the result, here are our hyperparameter tuning via a base with optimizer Adam and a feature space dimension of 256 and other important hyperparameters. Since we are using three class, so we will using a loss of multi-class clause entropy. For the image enhancement, we randomly picked 75 images. And based from the BIF, we have exceptional enhancement with a coefficient correlation of 961 and Spearman rank correlation of 0.958. So for the overall classification performance of our AWFC net, so you can see that in a tenfold cross-validation, its accuracy is 98.1%, F1 score 98%, precision 97.9, and recall of 98.1%. So what is the influence of the enhancement of images and the introduction of attention-aware mechanism on our architecture performance? So based on the table, so with SWF and with an attention-aware CNN, so the improvement is drastic from 0.884 to 981. So based at the right side on the graph, accuracy is 98.10 with the two special mechanism and a very low 88.40% if you remove those special mechanism. So what is the effect of the fusion of classifiers? So it increased the accuracy by 98.1% also, which outperforms individual models of GRU, ESN, and stack bidirectional long short-term memory networks. So for model convergent testing, so the train invalidation loss and the train invalidation accuracy demonstrated that the graph convergence has the lowest probability of overfitting and underfitting. So based on our visual explainability, so the higher value regions, which corresponds to warmer colors, red and orange, corresponds to the image's most significant areas influencing the CNN's prediction. So here are the how the model classified the tumors. So upon benchmark with existing recent methods for the last 5 years, Our method provided a more robust accuracy of 98.1% over different existing model architecture approaches and mechanisms. So the study presented a comprehensive deep learning architecture with multiple preprocessing and special mechanism. Our results indicate that our framework is accurate with 98.1%, 98%, 97.90, and 98.10% based on the overall classification metrics. So the color shifting in our spatial vinyl filter contribute greatly to the increased visual clarity without over changing the overall structure characteristic of raw mammogram based on VIF scores. Our ResNet XT101 with cardinality module overcame the challenges in extracting the minuscule morphological heterogeneity of the tumors. The addition of attention-aware module in the neural network's design reinforced feature learning by concentrating in regions of interest with subtle yet granular tissue differences. The integration of fused RNN classifier at the end of the pipeline complemented our special learning capabilities of our AWFCNet model by recognizing the temporal dependencies in data. So our GradCam also provided visual interpretability in terms of the tumor classification. So for limitation, we did not explore data for a set of general population that consider ethnicity, race, socioeconomic backgrounds, and other related variables. So really, a cancer is a debilitating illness affecting millions globally, and it remains the most pressing public health concern. As we look ahead, it is clear that continuous research and innovation are essential to combat the disease. We developed AWFCNet, a comprehensive machine learning model with various features for breast cancer classification. Our extensive experiments revealed its exceptional accuracy rate in pinpointing breast cancer subtypes compared with existing state-of-the-art approaches. It should be noted that combination of human expertise and machine learning could significantly lower diagnostic errors, especially on its early cases where the cancer is still treatable. For future work, the authors plan to improve the model's accuracy by exploring generative adversarial networks and transformers. Thank you very much for listening.